Hi, I want to talk about one of two special cases for projectile motion. And special cases are usually situations where we have hidden zeros. And in this first special case, we call it zero launch angle. So our hidden zero is the initial angle that an object is becoming a projectile is zero, which means the initial velocity is just the x component of the velocity. So the y component's initial value for velocity has to be equal to 0. So a couple of classic examples of zero launch angle. If a diver is just running off the end of a platform for a dive, that is zero launch angle, traveling parallel to the horizon. The other classic example, a plane dropping something. So that object starts off initially connected to the plane, so if it's flying at a constant speed and level, then the speed of the projectile is the initial speed of the plane, which is just traveling in the x direction. Now, once you have identified that you have zero launch angle, there are a couple of facts to make use of. The first, at zero launch angle, to have a projectile, you have to be falling. So that means your change in y has to be less than 0. And your change in y is going to be equal to minus the height that you fell. The other piece is the final component of the velocity in the y direction has to be negative. So if you are using a square root to solve for the y component of the final velocity, then you need to choose the negative value for that. And equations of motion. So in the x direction for any projectile, really the only equation of motion we have is that the distance an object travels is the speed in the x direction times time. Well, we could extend this because the time we could find given the fact that the initial velocity in the y direction is always going to be 0 if we know the height that the object starts or the distance the object fell. So our final velocity would have to be equal to minus the strength of gravity times time, because Vy initial is 0. Our displacement would have to be minus 1/2 times gravity times time squared. So if I wanted to solve for time first, well, I could multiply both sides by -2, divide both sides by g, and the time for an object falling with zero launch angle is always going to be the square root of -2 times delta y divided by the strength of gravity g. And this is where it's important to remember delta y has to be negative. We can't get a square root of a negative number and get real results, and motion is all about working with real numbers. So, g is always a magnitude, always a positive value. We already accounted for the negative sign in the acceleration with our equation. So, if I take this information that I have for time, I could plug it in and I could use this equation here to say that my final velocity is going to be minus g times time. Well, that would have to be equal to minus the square root of -2 delta y divided by g times g outside the square root. Well, the square root of g divided into g just gives me a square root of g in the numerator. So the final velocity, given the height of an object, is going to be negative the square root of -2 times the strength of gravity times our change in y. The total distance we fall with a minus sign in there. Thanks for watching.